Hello, this is Satbir. The topic of our discussion in this video lecture is how to find the concavity and point of inflections of a function. Let's begin by looking at the graph of this function, x cubed minus x. The function is concave upward where the bending of the curve is in the upward direction. So this is the portion where the function is concave upward. As you can see, the cave, this is a sort of functions look like have a cave, and the direction of the cave is an upward. On contrary, this is the portion where the function is concave downward, where the bending of the curve is in the direction of in the downward direction. And where the function change, it is concavity. That is the point is called the point of inflection or inflection point. So here in the graph, this is the point of inflection. Now question is how to find the interval where the function is concave upward and where the function is concave downward, and also how to find the point of inflection of a given function. So we will do this analysis to basically see that how we can basically build a test which is sort of find the concave up and concave downward for us. So if I calculate the derivative of this function, which is a 3x square minus 1. So I plot the graph of the derivative of the function when the function is concave downward. And I notice that the derivative of the function f prime of x is a decreasing function when the function is concave downward. And similarly, if I plot the graph of the derivative of the function when the function is concave upward, I notice that the derivative of the function is increasing. So in terms of the derivative of the function, the concavity is defined as follows. The function is concave upward when the derivative of the function is increasing, and the function is concave downward when the derivative of the function is decreasing. And the point of inflection is when the concavity of the function changes, when the function change from concave upward to concave downward. So we can build a test based on this analysis. So what will be our test to check the concavity? So first thing we notice that when the function is concave upward, so concave upward, the derivative of the function is increasing. And in the previous video, we have learned that if the function is increasing, its derivative is positive. So the derivative of this function will be the second derivative. So second derivative will be positive. So we can say that if the function is concave upward, it is second derivative must be positive. Similarly, we can define the concave downward will imply the derivative of the function is decreasing, and this implies the derivative of the function, the second derivative, because the derivative, one more derivative of this function is the second derivative of the original function, which is negative. And the point of inflection will be when the second derivative of the function is either 0 or does not define. So the inflection point implies if the second derivative of the function is 0 or in some situation it does not define. Let's take some example and practice this test on, apply this test on those example. My first example is a polynomial function. So I will again solve this problem in a 3 different steps. In step number 1, because I need to check the concavity, or in other words, I need to check when the second derivative of the function is positive or when it is negative. So first, in the first step, I will calculate the second derivative of this function. So my first derivative of this function is 12x to the power 3 minus 12x square and minus 12. And the second derivative of this function is f prime of x, 36 x square minus 24x, which I can simplify. I can pull out 12 as 3x square minus 2x. I can also pull out x, so the factor will be 3x minus 2. This is my second derivative of the function, and I also simplify the function, the second derivative, because I need to calculate in step number 2 the point where the second derivative is 0. So in step number 2, I will put second derivative of the function is equal to 0 and find x. So x will be 0 and 2/3, which is a slightly less than 1. So in step number 3, I will do the line test to check the sign of my second derivative. So here the test will be on the second derivative. So this line test, we are going to do it on the second derivative. So the first critical value is 0 of the first derivative, and the second one is a 2/3, which is a slightly less than 1. And then I will check the sign. So if I plug a number which is a less than 0, let's suppose -1, into the function, into the second derivative of the function, so this portion will gives me a negative number because this is a -1. If I plug -1 here, this will also give me a negative number. So negative negative will become positive. So this portion of the interval, the second derivative of the function will be positive. And now I will pick another point somewhere here and test the what is the sign of my second derivative. So you see that this number is a positive, so this gives me a positive. And if I plug 3/2, this will be 3/2, 1/2, that will be 3/2 minus 2, this will give me a negative. So this portion of the graph, the function is the second derivative of the function is a negative. And similarly, if I plug 1 here, so this gives me a positive, this gives me a positive, so the sign of the second derivative will be positive. So this tells us the function on this portion of the interval from -infinity to 0 will be concave upward. On here, function will be concave downward, and then the function will be concave upward again here. So concave up portion is -infinity to 0 union 2/3 to positive infinity, and the concave downward concave down will be 0 to 2/3. Let's take one more example, and this time we will take a bit more challenging example, which is a quotient function, 5/x minus 2. We're gonna do the problem again in 3 steps. In step number 1, we will calculate the derivative of this function, the second derivative of this function. So what is the first derivative of this function? First of all, if I will want to calculate the first derivative of this function, I would need to use the quotient rule. And if you want to practice the quotient rule, you have to watch another video which is especially discuss the topic of quotient rule. So how we calculate? We calculate the derivative at the top, which is a 0. We calculate the derivative at the bottom, which is a 1. And then we chant that line, low d high, high d low. So low d high, this multiply to 0, which is everything is 0. So 0 minus high d low, which is a 5 divide by x minus 2, the square of the low. So if I simplify it a bit more, this will be 5 over x minus 2, the square of that function. Now, when I will calculate the second derivative, I have to use the quotient rule again, but this time I will use the quotient rule on this function, minus 5 x minus 2 square. The derivative of the top is 0, derivative of the bottom is a 2 times x minus 2. Again, low d high, high d low. So low multiply to high, low is x minus 2 square of that. When it's going to multiply to 0, it's going to give me 0. And high multiply to low is going to give me minus 5 times 2 times x minus 2. And low, basically low square, x minus 2, the square of that is a 4. If I simplify this quotient, it will gives me on the top minus 10, and the bottom is giving me x minus 2 to the power 3. Because x minus 1, this will cancel 1 power from here. So this is the second derivative of my function. In step number 2, I will calculate the point. I will find the point where the second derivative is either 0 or does not define. So in step number 2, I will put the top and bottom both is equal to 0. But as I can see, there is nothing x in the top. So top has no x, and minus 10 cannot be equal to 0. So the critical value of the first derivative will come when I plug the bottom is equal to 0, which is x minus 2 to the power 3. This gives me x is equal to 2. So there is only one critical value in this quotient. So we will test this critical value in step number 3. In step number 3, if I do line test on this critical value, which is a 2, if I take a point on the left side of 2, let's suppose 0, and I plug that into the function, so you can see that a minus 2 to the power 3 is going to give me minus 8, and there is a minus 10. So the positive sign I will get a positive sign of the second derivative. This test is on the second derivative of the function. And if I take, let's suppose 3, if I plug 3 in this here, so this will give me a positive. Denominator has a positive, denominator is a negative, so this will give me a negative. So function is a concave upward here, and the function is concave downward on that interval. Here you might think that this x is equal to 2 is the point of an inflection, but it is not, because the function is not defined at this point. So this function does not have any point of inflection. So let me write here. The function is concave upward, concave up, minus infinity to 2, cave down, 2 to plus infinity, and inflection point does not exist. It does not have any inflection point. Compared to the previous example, this is a point of inflection, x is equal to 0 is a point of inflection, and x is equal to 2/3 is a point of inflection. But in this example, we do not have any point of inflection, because where the function change it is a concavity, that point does not belong to the domain of the function. Let's take one more problem, which is a quiz problem. So I would request you to pause the video for 1 and 2 minutes and practice what we have done in example 1 and 2 on this examples, and leave your answer in the link above, so you can compare with the other audience. My next example, which is example number 3, is this function, which is a bit more challenging. Then we have exponential function, which is a multiplier to a polynomial function. and we will find the concavity of this function. Again, in step number 1, we do the three-step problem again. Step 1, 2, and step 3. In step number 1, we will calculate the second derivative of this function. So f prime of x. This time we have to use the product rule because it's the product of two functions. So the derivative of the first function is a 1, derivative of e to the power x is as it is, and then x and derivative of e to the power x is as it is. So this is the product rule. The derivative of one function at a time the other function, and addition sign, and then other way around. So if I pull e to the power x, I will get 1 plus x. So this is my first derivative of the function. And I also simplify the derivative. Now I will use the product rule again and calculate the one more derivative of this function. So derivative of e to the power x is e to the power x. This is my first function. 1 plus x is as it is. Then e to the power x as it is, and derivative of 1 plus x is just 1, because derivative of 1 is 0 and derivative of x is 1. If I pull out e to the power x, I will get 1 plus x plus 1. And if I simplify, then e to the power x will be x plus 2. In step number 2, we will calculate where the second derivative of the function is 0 or not defined. Since there is no point where this cannot be defined, so we'll just put the denominator is equal to 0. And I will see that x is equal to -2 is one critical value, or where the second derivative of the function is 0. This function is always positive, so this will not give you any critical value. Now we're going to apply the second derivative test on the line test on the second derivative. I have only one point, x is equal to -2. I will pick a point, a test point on the left of -2. Let's suppose the -3. If I plug -3 here, that gives me a negative sign, but this is always a positive. So that is a positive. So this is a negative sign on this side. The second derivative is a negative on the left side of 2. If I take suppose 0 here and plug it here, so you can see that there will be a positive sign here, and positive got positive, the positive. So function is a concave downward here, function is a concave upward here, and x is equal to -2 is a point of inflection because the function changes in concavity. So concave up -2 to positive infinity, concave down is minus infinity to -2, and inflection points are basically -2. And if I plug -2 into the original function, my y value, this will be e to the power -2, which I can simplify. This is 2 -2 e square. So this is my point of inflection and concave up, concavity, concave upward and concave downward. So let's take one more examples, which is again a polynomial function, and calculate the concavity of this function. So again, this is going to be a three-step problem. In step number 1, we will calculate the second derivative of the function. F prime of x is 4x to the power 3 minus 6x to the power 1. And the second derivative of this function is (12x² minus 6). So if I pull out 6, is going to be 2x² minus 1. So in step number 2, we will calculate where the second derivative of the function is 0. So 6 2x² minus 1 is equal to 0. This implies x square is equal to 1/2 because 6 will divide over to 0. And then I add 1 on both sides and divide by 2. Therefore, x is equal to plus minus 1 over square root of 2, the square root of the whole. In step number 3, we will do the line test. So again, I have 1.1 over square root of 2. And I have 1 point here where basically I have minus 1 over square root of 2. Let's check where the second derivative is positive or negative. And if I plug 0, because 0 is in this interval negative 1/2 to 1/2, if I plug 0, I will see the second derivative of the function, because I'm applying this on the second derivative. The second derivative of the function is a negative. And you can check, you can take a point here on this portion of the interval. If you take a point here, you can take maybe 3, 4, whatever is. And if you plug here, you will see that the second derivative of the function is definitely going to be positive, and the second derivative is going to be positive. So from this, we can conclude the function is a concave upward, concave up on this interval minus infinity to 1 square root of 2 union 1 square root of 2 to positive infinity, concave down is minus 1 rad 2 over 1 rad 2, and the inflection point x is equal to minus 1 square root of 2 and 1 square root of 2, because the function changed the concave upward to concave downward, and then concave downward to concave upward on these points. Next, I have one more quiz questions. So pause the video for 1 and 2 minutes and practice on this problem, and leave your answer in the link above. And that's all I have in this video. And if you like this video, subscribe my channel and hit the bell button so you can watch my next video. So I will see you in the next video. Bye for now.